Hello, Avery. Welcome to the world, little man.
It's time for Maths with Mr. Thomas.
Here we go, Chapter 5, Lesson number 4. We're moving on to look at the standard deviation. Yeah! I'm splitting standard deviation across 2 lessons. What I'll do in this lesson is just look at the basics. It's how you find the standard deviation. And in the second lesson, we'll move on to look at really the part B standard deviation questions that pop up in the exam. It's when you're having to compare the standard deviation of a couple of data sets. But first of all, we need to know what standard deviation is. Do tell us! Okay. So, the way to introduce standard deviation, what I'm going to say is, imagine if you're in your class and you ask everybody to stand up. Well, everybody is going to be at different heights. There's going to be some variation in the heights. What could you do to measure the variation in all the heights of your class? Amanda. We can work out the range. Yes, Amanda, you are perfectly right. You could use the range to work out the variation. However, Andrew, what's an issue with using the range?
Well, the range only uses 2 values. If you've got somebody that's really tall, it's going to make the range massive. But that might not be a true representation of the class's heights.
Andrew, you are perfectly right. Yes, the range is just based on 2 values. And really, if there's any outliers, so if there's somebody that's really big or really small, then that's going to make the range appear a lot bigger than it really is. As I said in the last lesson, I went to school with somebody called Mark, and I met him in first year, and he was almost 7 feet tall. He towered above all of us, first year, second years, everybody in the school, including the teachers. And if you took the range for our class, the range would look humongous, but the variation isn't humongous. It's just that one person that's putting that number way up, so it makes it appear like there's a lot of variation when there actually isn't. So how could we combat that? What else could we use? Brian, do tell.
We could use the semi-interquartile range, or even the interquartile range.
You're perfectly right, Brian. Yes, you could. Why is the interquartile range a bit more accurate than just the range? Brilliant. It ignores any outliers. It just looks at that middle 50% of the data. So it would ignore, again, if you go back to the heights example, it would ignore anybody that's exceptionally tall, anybody that's exceptionally small, and it just looks at that middle 50%. However, once again, it's only looking at those 2 values. It's just the 2 numbers. So again, it may be slightly off. It may not give you a true representation of all of the heights or all the variation in your data set. I keep going back to heights for these examples, but it could be for anything at all. We need something that takes every single piece of data into account. And that is known as, say it with me, standard deviation! Perfectly right. Standard deviation takes into account every single piece of data and it uses every single number. What does it mean? Well, the deviation is how far each score differs from the mean, from the average. It's how far above the average or below the average. It looks at the variation there. And the best way to think about it just now, it's not strictly true, but the standard deviation is how far on average each score differs from the mean. If you go off to university, you can look at it in a lot more detail, see that that's not strictly true, but is the best way to think about it just now. Is how far on average each score differs from the mean. So it looks at each individual score and sees how far away it is from the mean. In order to work out the standard deviation, there are a couple of formulas that you get in the exam. Formulas! Yes, I know you love them. And the 2 equations that you get are this. Are you ready?
I'm ready! Hit me with it! Oh, yikes! Galloping yikes! What is that?
I know, that is the equation for standard deviation. It may look a bit complicated just now, but that's because I've not explained it. And once I do, you'll be like, oh my god, that's so simple, boy. So, that is one of the equations. And the other equation is slightly easier. No, it is this. That is the second equation. You are given them in the exam. You do not have to remember them. You just need to know how to use them. Phew, I'd never remember that. By the time you get to the exam, you probably will remember the formulas if you've practiced these enough. But they are given. With each equation, you need to know what all the different parts are. You've got the S, you've got the N, you've got the X, you've got the X with that big funky line on it, and you've also got this big funky E. What does that all mean? Let's go through it. So, what do you think S stands for when it's S equals? What is it we're actually having to find, Jack?
Standard deviation.
You're perfectly right. S just stands for standard deviation. You are working out the standard deviation. That is what the S stands for.
Oh, that's so simple.
It is indeed, Jack. Titus, what about the N? What is the N?
I believe that will be the number of numbers that we have.
You're perfectly right, yes. If you're looking at the standard deviation of the shoe sizes of 8 people, N is going to be 8. Because you've got the 8 numbers. If you're looking at the heights of 11 buildings, N will be 11. It's how many numbers, how many pieces of data you have. What is X? Brilliant. X just represents a single piece of data. I'll explain that just in the first example. I'll show you what I mean by that. X with a wee line on it. Oh, it's like X has a pure wee hat, man. It is indeed, yes, you're right. It's like it's got a pure wee hat. How do you say it though? You do not say X with a pure wee hat. What do you say? Brilliant, you say X bar. That is what it is known as. Just think of where Mr. Smith spends his Friday nights. And what does it mean? Do you get it? What does it mean? You're perfectly right. It is the mean. X bar is used to represent the mean. Woo! And this big funky E.
I recognise that.
Go on, Amanda. What is that?
It's one of the Greek letters.
You are perfectly right. It is one of the Greek letters. Mandy, which one?
Sigma.
It is sigma. It's one of the Greek letters. It's sigma. And what is it used here to represent?
It means the total.
It does mean the total, yes. Sigma is used to represent the sum of, the total of. And again, I'll explain that in this first example. But these are the two formulas, and that is what each part of the formula means. I'll go through 4 examples here and then show you how to work out the standard deviation. Are you ready? I can't hear you. I still can't hear you. Yeah, let's do it. Here we go. Example 1. Find the mean and standard deviation of these numbers here. 70, 72, 75, 78 and 80. I have not told you what they are. I've not told you their heights of plants or shoe sizes of giants. Just these numbers. Let's forget the units and just work out the mean and standard deviation. First thing we need to do is work out the mean. Just remember what represents the mean in this question when I'm using that formula that I like. X bar. It is X bar. You are perfectly right. And the way you work out the mean is by add them all up and divide by how many you have. Yes, perfectly right. Fast talking Frank. It's the total. It's what you get when you add them together. 375, and then divide by how many numbers you have. 5. If you do that on the calculator or in your brain, you end up with 75. Well done. So 75 is the mean. High five, fast talking Frank. After that, we're having to work out the standard deviation, and to do that, we do it with the assistance of a lovely table. No, not from IKEA. A table that looks just like this. Ooh, that's lovely. I know. So, the way you do it is you've got X, then you have X minus X bar, and then you've got X minus X bar in brackets squared. That is the 3 columns. With X, remember X just represents a single piece of data. So X is going to be the 70, then it's going to be the 72, then it's going to be the 75, then it's going to be the 78, and then it's going to be the 80. We have in this column X minus X bar. Remember, X is just our individual pieces of data. In this row here, we've got 70, so X here represents 70, and X bar is the mean. Good, so you do 70 take away the mean of 75, and 70 take away 75 gives you -5. Well done, so you get a -5. You don't actually have to write 70 take away 75, you could just write down the -5. I'm just putting that in there so you can see where it comes from. After that, you have got 72 take away the mean. So 72 take away 75 gives you -3. Well done. If you do 75 take away the mean, so 75 take away 75, that gives you 0. Well done. After that, you've got 78. So 78 take away the mean. 78 take away 75 gives you 3. Well done. And after that, you've got 80 take away the mean of 75, and that gives you 5. Well done. Fast talking, Frank. After that, what you want to do is you're wanting to add these numbers together to get a total. If you add them together, what I'd probably do is just start with the positive numbers. So 5 add 3, that gives you 8. And then just start taking the other numbers away. So take away the 0, 0. If you then take away the 3 and then take away the 5, you end up with 0. You do get 0. And we note, when you do this, you should always get 0 when you work that out. Unless your mean is rounded. If you get a number that you round for the mean, and then you're going to be out ever so slightly, so it means you'll be out ever so slightly from 0. But the majority of the time, you should always be getting 0 here. So we check to see if you are doing this right. After that, you've got x minus x bar in brackets squared. Well, remember, x minus x bar was this column here. So in the first part, we've got the -5, so it's just -5 squared. And remember, two negatives make a positive. Well done. So -5 times -5 gives you positive 25. After that, -3 squared is positive 9. 0 squared, 0 times 0, 0. 3 squared, 3 times 3, 9. 5 times 5, 25. Well done. And once again, we want the total. So add 25, 9, 9, and 25, giving you 68. Well done. So that is our table. After that, we're going to the formula. Remember, there's two formulas, but there's only one that I like, so that is the one I'm going to use. This formula, even though it looks confusing, is actually dead simple to use. The square root will stay as the square root, but this whole top line, remember, what does sigma mean? This big funky E. Oh, the big funky E, man! Well, that just means a total! It does indeed, yes! That is the total of the x minus x bar squares. And the x minus x bar squared, the total of them was 68. So that whole top line becomes 68. So we'd have the square root of, and the top is 68. And we want to divide that by n, take away 1. What's n? How many numbers do you have? Good, how many numbers do we have? 1, 2, 3, 4. That's right, 5. If you take away 1, you have 4, so we're dividing that by 4. So it's the square root of, make sure the square root goes over the whole fraction, square root of the 68 all over 4. If you want to simplify that, well, that's just the square root of 17, and the square root of 17, doink, 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 get into the calculator, and you end up with 4.12. Yeah! That is how you work out the standard deviation. Remember, the standard deviation is a measure of how spread out the results are. This lesson, though, is all about just working out the standard deviation. What I'll do in the next lesson, the video after this, is look at comparisons. So the standard deviation is this for one group, this for the next group. What does that mean? But just now, it doesn't mean an awful lot on its own. However, what I will say is that if you end up with a high number for the standard deviation, well, it means the results are fairly spread out from the mean. In other words, they're more varied. If you have a low number, though, what it means is that the values will be close to the mean, so there's less variation in the results. So you may have something that looks like this. Again, if you had a number line, you may have the mean here, so the points might be a bit closer to the mean. There's not as much variation. That is what the standard deviation is all about. And as I said, if you look at the next lesson, that'll give you a better idea of how the standard deviation can help you when you look at the variation in different questions and different results and so on. Let's try another example. Find the mean and standard deviation of 9 meters, 12 meters, 15 meters, 19 meters, and 20 meters. Just remember, you're asked for two things, the mean and the standard deviation. So to work out the mean, remember, you work out the mean by doing... Brilliant. It's the total divided by how many numbers you have. And remember, x bar represents the mean. So to work out the mean, get the total. 9 add 12, add 15, add 19, add 20. Divide that by how many numbers you have. 1, 2, 3, 4, 5. Brilliant. So 75 divided by 5, 15. Brilliant. So there would be a mean of 15 meters. Yeah. After that, we need to think about that table where we've got x minus x bar, and x minus x bar all squared. So x represents each individual piece of data. So x will represent these 5 numbers here. So x is going to be the 9, the 12, the 15, the 19, and the 20. You can put them in any order you like, but they are in numerical order here. So that's just the order that I am putting them down. X minus x bar, remember x bar is the mean. So we're taking each number and taking away the mean. So we'd have 9 take away the mean of 15. 9 take 15 is negative 6. Do it for the next number. Start with the 12 and take away the mean. 12 take away 15 is negative 3. 15 take away 15 is 0. 19 take away the mean of 15 gives us 4. And 20 take away 15 gives us 5. Just remember a little check at this point. Add these numbers up and you should be getting 0. I would always start adding the positive numbers. So 5 add 4 gives us 9. And then from there, what I would probably do is just think 5 add 4 is 9. And then if I take away 3 and then take away 6, does that give you 0? It does indeed. That should be checked to see if you are getting this right. Remember, the majority of the time, that column will add to 0. The only time it won't is when your mean was a rounded answer. If you get a decimal that goes on forever, and ever, and ever, and ever, and ever, and ever, then round it. But it means this will be out ever so slightly as well. But we're getting 0 for this, so let's keep going. X minus x bar all squared. Well, that's x minus x bar. All we've got to do is just square that number. Remember, when you square a number, it always becomes positive. Well done. So, negative 6 squared is negative 6 times negative 6, which gives us 36. Negative 3 squared, negative 3 times negative 3 gives us positive 9. 0 squared, 0 times 0 is still just 0. 4 times 4 is 16. 5 times 5 is 25. And if we add all of them together, we end up with, key it in the calculator, doink, 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 86. Woo! From there then, we can use the formula. That is the formula that's on the formula sheet. And remember, the whole of that top line is just the total of the x minus x bar squareds. So the total of the x minus x bar squareds was what we got when we did 36, add 9, add 0, add 16, add 25, and that was 86. So that top line is 86. And we'll be dividing that by how many numbers we have. Take away 1. We have 5 numbers here. Take 1 away. Oh, that's difficult, but I can do it. It's 4. Well done. So it's the square root of the 86 divided by 4. 86 divided by 4, if you work that out, it's 21.5. And if you take the square root of that, it gives you 4.64 meters. Yeah. Example 3. Find the mean and standard deviation of these 4 weights. 4 kilograms, 12 kilograms, 9 kilograms, and 6 kilograms. They are not in order. They don't need to be. They could just be all messed up. It makes no difference. We've got the 4, the 12, the 9, and the 6. We want to work out the mean. First of all, remember the mean is x bar. That's how you read it. It's x with the wee line above it. Don't say x with the wee line above it. Say x bar. So, x bar is the total. It's the 4 add the 12, add the 9, and the 6 divided by how many numbers we have. That gives you 31. Divide that by 4 and you get 7.75. That is our mean. If we draw up this lovely table, we've got x minus x bar, and x minus x bar in brackets squared. X is the individual pieces of data. So we've got the 4, we've got the 12, we've got the 9, and we've got the 6. Woo! With each of these, we're wanting to take away x bar, which is the mean. So we would have the 4 take away the 7.75. 4 take away 7.75 gives us negative 3.75. Do the same with 12. 12 take away the mean of 7.75 gives us positive 4.25. If we do the 9 take away the mean, so 9 take away 7.75, we get 1.25, and the 6 take away the mean, 6 take away the 7.75, gives us negative 1.75. So that is our x minus x bar. Once we've done that, remember a little check to see if you are getting this right. Well, we just have to add all these numbers together. So negative 3.75, add 4.25, just add them all. Again, what I'd probably do is just start with the positive numbers. If you add them and then just start taking away the 1.75 and take away the 3.75, check that you get 0! Which in this case, you do. Remember, this value should always be 0 unless your mean is rounded. Then it'll be out ever so slightly. X minus x bar all squared is just going to be this number squared, and this number squared, and this number squared, and this number squared. Just square each of the numbers. Just remember, if you have the negative 3.75 times the negative 3.75, remember your squared number, so it's just the exact same number multiplied by itself. Two negatives make a positive! Well done. So we'd end up with positive 14.0625. 4.25, if you square that, multiply by itself, you get 18.0625. 1.25, square that, and you end up with 1.5625. And the negative times negative will again make a positive. And 1.75 squared is 3.0625. Add all of these four numbers together, and you end up with 36.75. Well done, Amanda, doing that in your head. High five. From there, we are wanting to use the formula. That is the formula that's given on the formula sheet. Ooh, lovely. So, now we just need to plug in our values. But remember the whole of the top line. What's the whole of that top line going to be? 36.75. It will be 36.75. Why? Yeah, because that sigma just means the total is the total of the x minus x bar squareds. And the total is 36.75. So when we bang that into our formula, boom, 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 that top line is just that 36.75. We're dividing it by n. Take away 1. What is n? How many numbers we have? How many numbers have we got? Well, in the question, we've got 1, 2, 3, 4. Take 1 away, and it gives us 3, so we're dividing that by 3. If you work that out, you could just go straight to your answer if you like, or if you do the 36.75 divided by 3, you get 12.25, and if you work out the square root of that, well, everybody knows that. It's 3.5 kilograms, obviously. Yeah. Last example. Here we go, example 4. Work out the mean and standard deviation of 3, 5, 2, 9, 1, and 8. So we've got 6 numbers here. Once again, to work out the mean, the way we work out the mean is by adding them all up to get a total and dividing by how many numbers we have. Remember, when it comes to standard deviation, the way we write down the mean is by using x bar. So x bar is the total divided by how many numbers we have. So that's 28 if we add them together. Divide that by the 6 numbers, and this time we end up with 4.66666666666666. It's just a decimal that keeps on going, so we are going to round this number. So rather than writing 4.66666666666666666666666666, we could just write it as 4.67. Probably keep it to at least a couple of decimal places. We then want to take each of these numbers when we put it into our lovely table. So x is 3, it's 5, it's 2, it's the 9, it's the 1 and the 8. Yes, it is just these numbers we have here in the question. And we're going to take away the mean. So we would do 3 take away the 4.67. We would also do the 5 take away the 4.67. We would do the 2 take away the 4.67. Each of these numbers we're just wanting to take away that mean of 4.67. So 1 take away 4.67 and 8 take away 4.67. Once again, we can do a little check. We can add all these numbers together. What should we get? 0! But will we in this one? No, we won't, because our mean has been rounded. Perfectly right. Good. If we add these numbers together, you just bang them into the calculator. You end up with negative 0.02. Ooh, that's not quite 0. You're right, it's not 0, but it's because we have rounded this mean. So we are out ever so slightly. So we're out ever so slightly with this column here. It will not be 0, but it will be very, very close to it. That's fine. We then want to work out x minus x bar squared, so we're just taking this number and squaring it. So we're doing negative 1.67 times negative 1.67. Two negatives make a positive, and if you do 1.67 times 1.67, you end up with 2.7889. Square 0.33 as well, we can write that down. Square the negative 2.67, again a negative times a negative becomes a positive. Every single one of these numbers here is always going to be a positive in this column. Square 4.33, put these in the calculator. Square negative 3.67 and square 3.33, and we'll get these results. Again, just check that these are always going to be positive because we have squared a number that will always be positive. If you add all these numbers together, what do you end up with? Well done, you're perfectly right. You would end up with 53.3334. Now we've done that, we can go off to that formula. So that is the formula that's on the formula sheet in the exam. Remember, S is for standard deviation. So the standard deviation equals, and this formula, even though it looks confusing, the whole of the top line is just that last number that we wrote down in our table. We added all these together and we ended up with 53.3334. So that is that top line there. So it's the square root of the 53.3334, and we're dividing that by how many numbers we have. Take away 1. Well, we've got 1, 2, 3, 4, 5, 6 numbers. So if we take 1 away from that, we'll be dividing that by 5. Yeah! Again, you can work that out on the calculator and then write it down, the square root of whatever, but probably just go straight to the answer because, again, we're going to have a rounded answer. So to try and limit the number of rounded answers we're writing down, just go straight to the answer of 3.27. Again, the units, I've not told you it's kilograms, pounds, meters, whatever. So I'm just missing that bit out and just doing an example without the units. But if it makes you happier, just write the word units at the end there to show you have remembered them. Yeah! That's it. That's 4 examples for standard deviation. Hopefully that has been enough. Go away and practice it. There's some questions in the TJ National 5 book, page 113 onwards. Questions 3 to 6. Once you're comfortable with that, move on to the next video, the next lesson, which looks at comparisons. It's comparing a couple of different groups and saying what the standard deviation actually shows you. And also remember, that's just one of the formulas for standard deviation. That's my personal favourite. That's the one I prefer. So that is the one that I teach. If you want to see the other one, you will have to look elsewhere, I'm afraid. Sorry. But there we go. That is how you do it using that formula. See you later. Bye. Do you want to say bye, Avery?